I guess we'll go ahead and get started. Hello to everyone in the future watching this video recording. I'm Andy. I'm a software developer at CodeHS. I'm joined by Claire and MR. They'll be able to answer any questions we have in chat. Just send anything and I'll be able to see it, or they'll be able to answer it. So what we're going to be talking about today is Juice, and we'll explain what that is. But we're also going to be learning about JavaScript modules and how you can use code or libraries that other people write. In this case, code that I wrote in JavaScript programs that you make on CodeHS. So first, a working definition of what Juice is. Juice is a concept in user experience and video game design, and it's kind of a term for a specific way that interactions can feel good. So a juicy interaction is satisfying and rewarding. It's the kind of thing that you want to do again. So we might be able to think of Juice as the ratio of feedback to input. So for example, if you get a lot of feedback, it's tactile audio feedback back from something, and you only put a little bit of input in, that's a very juicy interaction. So what are some examples of Juice? The first one here is an animation from a classic arcade game, Street Fighter. And this is considered really juicy because this is what happens when you don't interact with the game at all. If you're not touching the game at all, the arcade cabinet, the character is still moving, and you still get this feedback to know that, okay, the game is doing something. A slot machine is another really good example of this. A slot machine is really just a random number generator, right? It's really just you get a random number out, and if that number is 1 in a million, you win. But to make that experience more satisfying, more juicy, you actually have a handle that you need to pull. You need to move that through space. And when you do that, you feel resistance from like a spring, and then it kind of clicks into place, and then those dials rotate and they make a clicking sound when they do. When you finally win, you get the feedback of the coins clattering around in the metal collector at the bottom. So there's a lot of feedback that you get there, even though all that the game actually needs to do is create a random number. It gives you all of this additional feedback. And then I think a kind of more modern example that we can all relate to is Wordle. What happens in Wordle when you enter an invalid word? All that it really would need to do is say not valid, but you can see that it shakes its head back at you. This is a design that comes up in iOS design. This is where this kind of first took off, is the idea that when you do something invalid, it kind of shakes at you to say this isn't right. So the key thing here is that Juice is adding to how we perceive something. It doesn't interrupt the function of what we're working with, but it can change your perception of it. So in the case of Wordle, saying that you have an invalid word, this is just a more interesting and a more juicy way of saying, no, this word wasn't valid. So let's take a look at this in the CodeHS sandbox. This is an example that is an HTML program that I made. And what we have here is just two switches. One is a checkbox, and one is a slider checkbox. Again, this is a design that was kind of cooked up for iOS, for Apple phones. And an important thing here is both of these do the exact same thing. When I click this top checkbox, the bottom one turns on. When I click the bottom one, the top one turns on. These are functionally identical. They are two things that when I click on it, it toggles to the on state or it toggles to the off state. But I'm going to say that one of these is a lot juicier than the other. The top one, just as soon as I click it, okay, it's now blue, it's now on. But the bottom one kind of moves through space, it changes color, it has this kind of like shadow effect around it, right? And a key thing that I think I want to extract here is this bottom checkbox is based on something that we see in real life, right? I have a portable radio that has slides just like this, like little switches that you toggle back and forth. But this top checkbox is just kind of like, it exists in a little bit of like an imaginary land where instead of on a form like checking a checkbox, it just immediately becomes checked, right? This bottom one, we can think of what sound would this make? What would it feel like to slide the slider back and forth? But the top one is just kind of like on and off. In real life, a light switch is something that you actually have to move up and down. But here, this top one is just something that is either on or off. This top one's not as juicy. So what is the key thing here? What is the difference between computers and real life, and what makes real life juicier than computers? On computers, you can have discrete states. Something is either on or off, something is at point A or point B. But in real life, you have infinitely continuous states. For example, if you want to move a ball from 10 feet off the ground to the ground, a computer can just immediately put that ball there, right? Like I have on the left, the ball is just immediately at the bottom. But in real life, it actually has to move through space. And additionally, the way that it moves has some nuance to it, right? A very large ball or a balloon is going to move through space differently than a bowling ball. In computers, you can have things teleport. They just immediately go from point A to point B, but in real life, they have that kind of nuanced movement. And in computers, things exist in a void, right? This is an important aspect which comes up a lot, which is anytime we want to create an effect in a computer, we have to manually add it. Whereas in real life, those things just happen based on the laws of nature, right? So in this example on the right, there's like this really interesting effect that happens, which is, okay, what happens when you have two balls stacked on each other? But also notice what happens when the ball hits the ground. You can see that the camera shakes a tiny bit. You can see that the camera kind of wobbles up and down. You can also see that there are shadows. You can see that things kind of move in random directions a little bit. So the key thing that we're going to be trying to do with Juice is how can we make our programs that we make in CodeHS work more like things would work in real life, because things in real life are kind of inherently juicy. And so we see this idea in user interface design all the time. An app like Tinder, which kind of, introduced the idea of swiping. All you're really doing is saying yes or no, but Tinder created the parallel that you're actually moving pictures of people left or right. It's connecting it to real life. This rotating clock selector in iOS, all you really would need to do is enter those numbers, but to make it juicy, Apple connected it to the idea of a dial that's rotating, and it kind of vibrates when you rotate it. And the trash can on Mac computers, again, Apple has a lot of really juicy design. When you empty the trash can, it makes like a paper crinkling sound. Completely unnecessary, but by imitating what happens in real life, it's suddenly more satisfying to empty the trash. It's more satisfying to swipe left or swipe right. And one important thing to remember from this is juicy interactions feel good. And we see this with slot machines, right? Slot machines are very juicy. Anytime you experience juicy user experience or a juicy game, be aware that they're probably trying to get you to do that thing again. So for example, the game Fruit Ninja. The point of this game is that they want you to play it as much as you can. They want you to want to keep playing this game. And on Twitter, for example, refreshing a feed is really juicy. When you swipe up, it has this kind of elastic stretching effect, and then it kind of pops back in place. And you can't hear this because it's just a GIF, but it makes a really satisfying sound. It has a kind of sound that it makes that is really rewarding, and it makes you want to refresh again. And Twitter wants you to refresh because they want you to be addicted to the app. So keep this in mind. Anytime you're working with an app or something on your phone and you get this really satisfying experience, that's probably the designer trying to cover for the fact that, maybe it's actually slow in the background, or maybe it's just something they want you to do again. So we're going to talk about how you can add juice to programs, and we're going to look at some examples in the CodeHS sandbox. A really common technique is called tweening or lerping. This is short for in-betweening or interpolation, linear interpolation. This comes up a lot in 2D animation. So this is a still from SpongeBob where you can see that Squidward's face is stretched. This is between two frames. They add these frames that kind of change how things move through space. And this is what I said before, right? Computers have the ability to teleport an object from left to right. So in this example on the right, the ball could immediately move to the right side of the screen, but I'm showing two different ways that the ball can make that journey. In the first one, it's moving at a constant velocity from the left to the right. And in the second one, it's doing something called quadratic ease. Let's take a look at these. So this is a sandbox program I made. MR can share out the link to this one. So what we have here is I've created a gallery of different easing functions. So these are just different ways that an object can move from point A to point B. Yes, the slide deck will be shared. Any way that an object can move from point A to point B. The simplest one is linear. So this ball just moves from the left to the right. And what you can do is you can choose between any one of these easing functions and see what does it look like if you move according to a cubic function, right? So the x-axis is time and the y-axis is distance from the left. So you can see that we have a couple different functions that you can use. You can do an ease out quadratic, which means that it kind of slows down when it reaches its destination. And this is just a really fun tool to play with. We'll send out this link and you can play with this whenever you want. But an important thing to think about is, what does this movement indicate to you? All that this is a mathematical like formula indicating how much a ball should move. But for example, if we look at something like this, not that one, this one, no, not even that one, sorry, this one. Now the ball is bouncing, right? This is just a simple mathematical relationship between time and distance, but now we can say, oh, that's a bouncy ball. And additionally, we might have something like this, which is like, oh, this ball is like kind of being really tugged and then it moves quickly and slows down. Again, this is kind of this way that we're relating things to real life. And based on that, we're making it a little bit more juicy. So this is called easing, and it's a really common technique that you'll see to make things juicy. Anytime something moves from point A to point B, think, okay, it could be a little bit more interesting if we used an easing function. So the next thing we're going to look at is stretch and squash. Again, this is really common in 2D animation. You see this all the time in Looney Tunes and Disney. The idea being that when an object touches a surface, it kind of squishes, and when it leaves that surface, it stretches. So you can see here an animation loop where when this object collides with the ground from frames 8 through 11, it flattens, but when it leaps off the ground, frames 2 to 4, it stretches. This is something that I don't really have in the tools I made. The code for this is a little messy. I wasn't a fan of it, but this is something that you might see anytime you're playing a game or something. You might see this kind of squishing and stretching. So the next thing we want to look at is sound. And sound is an incredibly useful tool for Juice. Just think that anytime anything happens in real life, unless you're like in a vacuum, you're going to hear a sound. And that should be true in a computer program as well, right? But like I said, we have to make the conscious decision to add that sound. So this is a really useful example for demonstrating that. And I'm going to try to share my sound here. We'll make sure that works. But I created a program where we have a ball moving from the left to the right? Very simple. We also have a ball moving from the right to the left. We have two balls moving across the screen. So together, they're just going to pass by each other, right? And that's what we're seeing here. These two balls pass by each other. What I'm going to do now is add a single sound, and we're going to see how that changes our perception of what happens. So if you can hear that, a sound plays as soon as the balls pass by each other. And now our perception is totally different. Whereas before it seemed like they were passing by each other, now it seems like they're actually bouncing off of each other. I didn't change anything about the animation, I just turned the sound on. And additionally, the sound that we choose can give us different information about what's going on. So I'm going to just choose a different sound effect. Now it sounds like the balls are kind of like, I don't know what material that would be. It sounds kind of like glass. But it being a higher pitched sound means, okay, these are not like these crunchy, maybe rocks that we had the first time. They're instead something made of glass, maybe. So sound is an incredibly useful tool. And you see this in early days of video games. Games like Mario really kind of took this to the next level. I mean, Pong was one of the very first games to have sound. It kind of just had that blipping. But a sound can make something so satisfying. And done right, it's really great. It makes you want to keep doing the thing. But done poorly, it can be really kind of obnoxious. And so that's why sound design in games is really important. So the next thing we're going to look at is shake. And shake is kind of a notorious aspect of Juice because it can be really overdone. We're going to take a look at an example and see what does adding shaking say to us as a user of this program. So let me run this. I don't know why it's sized that way. Okay, so what we have is a couple fleas, and when I hit 1 through 5, they'll jump. What I have is the first 4 fleas seem like fleas, but if I jump one at a time, the 5th flea seems like it's much heavier, and that's because the screen shakes when it hits the ground. I've changed nothing about the animation, just made it so that when the 5th flea hits the ground, the screen shakes. And so this gives us, the user, the feeling that this is a very heavy object, right? This is like an imposter. This isn't an actual flea. And so screen shake does the same thing, right? In real life, if you drop something heavy, things kind of shake. And additionally, we have this kind of drawn from videography, right? The amount of culture that we consume that's recorded with a camera will shake when something happens. And so a lot of like CGI movies will have to add screen shake afterwards when like, Thanos or a dinosaur or whatever does something. They make it appear that the screen has shaken, that the camera has shaken. And we're doing the exact same thing here. Okay. So the key takeaway before we look at how we would implement this ourselves is that life is full of meaning. When you connect to life, you can draw from our lived experiences. So if I make it so that the screen shakes when something happens, we're suddenly like, oh, when would my vision shake in real life if something really heavy hit the ground? And also like, if a ball moves from left to right very quickly, you're like, oh, when would I see that? Maybe if somebody's throwing something or if it's moving through water. But if it moves slowly, you're like, oh, that's similar to how I would see something move through molasses or mud. And so by drawing on those lived perceptions that we've created from decades of living, we're able to make our programs feel more lifelike. So the next thing I want to do is talk about how you can integrate Juice into your programs on CodeHS. And I've tried to make this as simple as possible. There's a little aside that we can talk through. We'll send out a link for this on how modules work in CodeHS, because what we're going to be doing is using a JavaScript module. But what we're going to be doing is going through and looking at the juicebox, which is a module that I've created for adding juice to your programs. So I'll send out this link in chat in case, or unless MR sent it out. Let me pull up the chat. So there's the link to the documentation for juicebox. And I'm going to go through this and explain the different parts that we have here, show you how they would work in a CodeHS graphics program. And then we're going to walk through a live example of adding juice to one of our programs. So juicebox is a library for adding juice to CodeHS JavaScript graphics programs. To include it, all you need to do is add this line to the top of your program. So in all of these examples, you'll see that's the very first line. That automatically makes some changes, but then there's different features that you can use to create different behaviors. So the first one we're going to be looking at is the idea of growing objects. So what I've done is I've imported juice from that URL, right? I've included that first line. And then on line 4, I say juice.grow equals true. What this means is when objects appear on the screen, they actually kind of bloop into place. And I think it'll make more sense if I show you that. So when I run this program, you can see that the segments of this snowman kind of have this elastic effect. They appear like they're popping into place. So if we look at this program without that, we just have 3 dots of the snowman. It's a little bit boring. And if we turn that on, we have this kind of elastic, exciting effect, right? This is kind of juicy. So you say juice.grow equals true to get that effect. The next is slam. This is an alternative way for elements to be added to the screen. When you say juice.slam equals true, when objects land, they come in from the top and kind of create a shake when they fall. So the idea is, the segments of your snowman are falling from the top of the screen and landing at the bottom. You can also set juice.ooze to true. When you do this, an object, rather than teleporting from point A to point B, will use an easing function to get there. So what I'm doing is teleporting a ball around, but because I said juice.ooze equals true, that ball will now kind of move continuously rather than teleporting. So I'm going to turn that off to show you what it looks like otherwise. It's a teleporting ball, doesn't feel very lifelike, but as soon as I turn ooze on, this ball is now kind of moving continuously. It feels a little bit more lifelike, hopefully a little more juicy. So you can also turn sound on by saying juice.sound equals true. When you do that, when an object gets added to the screen, it will make a little sound based on how it was added. So in this case, let me unmute. So objects that bloop into place will make that little growing sound. Objects that fall will make a little falling sound. I don't think I did a great job designing the sound, so I think that they get a little obnoxious. So I made it so that you can turn these off. The next is if you say juice.blend equals true, anytime an object changes colors, it will kind of blend those colors together rather than immediately changing the colors. So I'll turn that off and you can see this object just changes colors every, half a second or so. But if I say blend is true, we get this interesting blending of colors where it's kind of like, I don't know, it's kind of like a chameleon almost, right? Just the idea that in life, if something changes colors, it's going to do it continuously. So there's another flag you can set here. You can turn the lazy add off, which is just in, that'll come up in some of our examples. But the next thing I want to show are some functions that you can call that will add some juice to your program. The first one is juice.dust. And this makes a little wisp of dust. The idea being, like I said, in real life, if you drop an object on the ground, there's going to be some effect that happens. If you drop it outside, there's going to be like a little kick of dust or particles or whatever. So by calling juice.dust, when this ball hits the walls, it kicks up a little burst of dust. It makes it just feel a little bit more lifelike, right? Like our ball is actually colliding with something. There are different arguments you can pass to the dust function, which I talk about here. But usually all you need to do is call juice.dust and give it an X and a Y position. Then you can manually create some sounds. If you call juice.bonk, it creates like a little bonking sound. So if I do that anytime the ball hits the walls, it creates the effect of actually like, give some weight to it. So let me unmute that. It's right in the corner. So let's wait until it's not in the corner anymore. So here we go. So just like Pong or another arcade game you might have played, it gives it a little bit more like feeling of actually something actually happening. So you can also do juice.fall, which will make that little zipping sound. Sounds like a laser, so I put lasers behind it. And then we have a couple effects that you can also use. One is juice.shake, which, like I mentioned, kind of gives the feeling of weight, like something, kind of heavy is happening. So in this case, when this ball hits the ground, I shake every object. So when I click, it jumps. And when I hit, everything shakes. It gives the feeling that this is like a bowling ball, right? It's a really heavy object. And the final one is juice.shockwave. This creates a shockwave effect at the X and Y coordinate. So all you need to do is call juice.shockwave and give it an X and Y position, and it'll create this ripple effect. So those are the different functions and flags that are available in the juicebox library. What we're going to look at is how you can actually add juice to one of your programs. And I'm going to go ahead and do this with two different programs. I'm going to do this with a more basic program from the beginning of our JavaScript graphics course. And then I'm going to do it with Breakout, which is kind of our capstone project. So if you have students who are working through the JavaScript course, this might be a fun final thing for them to do at the end. So one of the most basic programs is, let me think of which one I want to do. Let's do eggs and let's do the flag of the Netherlands. So these are two pretty early programs in the course, right? Flag of the Netherlands is, I think, in Unit 3. And this program makes the flag of the Netherlands, right? Which is, just 3 stripes, red, white, and blue. And what we're going to look at is how do we make this program juicy, right? This just kind of draws a flag now. So what we're going to do is follow the instructions from these documentation. What we're going to do is copy this line, this import statement, and we're going to put that as the first line in our program. So just by including that, we're going to see a change immediately, which is that instead of things adding immediately, they add one by one. So we have the first line and then the final line. But what we can also do is make them slam into place, which I think is going to be a pretty fun effect. We can do that by saying juice.slam equals true. And now when those stripes add, they're going to fall from the top down. So you can see that the red line immediately falls, but then the blue line falls from the top and hits the bottom. We can also say juice.grow equals true. And now they'll kind of bloop into place. So you can see that they come in and they kind of wobble, which I think is fun. It looks like it's a flag made out of Jello or something. So that's all you need to do to make one of your most basic graphics programs juicy. And now this is like a pretty fun program to interact with, right? Every time you run it, it's like a little bit exciting and pretty fun. The next one we're going to look at is eggs. So again, I'm going to take my juice code out and we're going to just look at the program as it is. Oops. Some extra stuff I had written before. So this is a graphics challenge. This shows up a little bit later in the JavaScript course, but the idea is you draw a plate of eggs. And we're going to do the exact same thing that we did before, where we copy this line and put it as the first line of our program. And then the next thing we're going to do is say juice.grow equals true. And this makes it so that anything that we add to the screen has this kind of elastic effect. So when we run this now, we have this really satisfying thing where like the pan kind of plops in and then the different pieces of the eggs plop in. I think this is so much fun. And then if we say juice.sound equals true, let's hear what that sounds like. It's a little bit much, but I don't know. I think it's kind of fun to overdo it and then pull it back a little bit. So we're going to look at a more complicated example now, which is how you would add juice to a game like Breakout. So let's take a look at this Breakout game that I've created. Let me real quick remove all of the juice that I added before. Okay, great. So this is just Breakout. This is kind of the capstone of the intro JavaScript course. What you have is a Breakout game, and you bounce the ball off the paddle and the bricks break. This is fun. I think it's a pretty interesting game, but I'm going to try to show that when we make it juicy, it's a lot more satisfying to play. So again, how do we add juice? The very first thing that we need to do is add this import statement at the top. Now when we run this, we see that the first change is that the bricks will add one by one, the ball will add, and then the paddle will add. So that's the first thing that adding juice does, is it makes it so that things don't just teleport in, they come in one by one. The next thing I want to do is say juice.slam equals true. This means that the bricks are going to kind of come in heavy from the top, and then the ball and the paddle will drop in as well. So that's already a little bit more juicy. I don't know why that sizing is off. I think it's because I'm zoomed. Let me see if I can fix that. Okay, there we go. So I was just too zoomed in, so things were getting a little bit strange. Okay, so the next thing that we want to do is, this game's again working, and a neat thing that happens is if we lose, the text that says game over is going to slam in from the top. Pretty fun. But what I'm going to do next is use dust and shake to make this even more exciting. What I'm going to do is add dust anytime the ball hits the wall, the paddle, or a brick. So we can go into the code and find these places. This is just based off the solution code, which you should have access to. So I've just copied the solution code right in here. So what you see here will be exactly what you see in the solution reference. So what we need to do is find what happens when the ball hits a wall. That happens in the check walls function. So this means that the ball has hit a left or right wall. This means that the ball has hit the top. So what we're going to do is anytime the ball hits one of those, we're going to say juice.dust, and we're going to make a dust burst at ball.x, ball.y. We're going to do that when it hits the sidewalls or when it hits the top. And then additionally, anytime we collide with an element, we're going to add a little burst of dust there as well. Let's run that. So now we wait for all our bricks to fall in. And now when we run it, we get a little burst of dust anytime we hit something, which has already made it a little bit more satisfying to collide with objects, right? It's pretty fun. The next thing we're going to do is make it so that the screen shakes anytime we collide with something, which is going to give the effect that like we're kind of bouncing a really heavy, impactful ball around, which I think will be really fun. So in all the same places that we added dust with juice.dust, I'm just going to say juice.shake. So that's whenever we collide with the paddle or the bricks, which is here in check objects. And then additionally, anytime we hit the wall, we're going to add a shake. So now what happens? Wait for all the bricks to fall in. Now we get this cool little shake effect. You can see that the bricks kind of jostle, which gives the feeling that like this is like a pretty heavy ball that's bouncing off of them. Everything kind of wobbles. The final thing that I'm going to do is I'm going to make it so that we get a sound anytime we collide with something. So in all the same places, I'm just going to add a juice.bonk. So that's whenever we hit the top wall, oops, whenever we hit the side walls, and whenever we collide with an object. Let's go ahead and run that and see how that sounds. So this already feels so much more like a interactive, exciting game that I think is a little bit more satisfying to play. And especially if you get a good combo where the ball hits a bunch at once. Let's see if I can get that without losing. So we got 2 there. Okay, I'm not great at breakout. Let's try once more and see if I can get a bunch at once. I'll give it a little bit more time and see if I can get a good combo. No, I couldn't. So just with a couple lines of code, adding dust, shaking, and 1 sound, this game is a lot more interesting than what it was before. And so the idea is the juicebox, this library, is something that you can take with you back to your classrooms. And following the instructions that I give on this page that I sent out, you and your students can take your JavaScript programs that you may have written at the beginning of the year, you may be tired of now, you think that they're boring and worn out, you can now make them interesting and exciting and kind of breathe new life into them. Additionally, you can take something that you may have made in the sandbox and make it a lot more interesting. So, I'm going to try to find an example of what I have here. So, for example, I have, let's see, this example here. This is just a bunch of balls and they bounce around the screen. But you can see that when they appear, they make a little bloop. And when they hit the sides, they make a little kick of dust. It's a pretty fun program I cooked up that just uses Juice to kind of make something that's pretty fun to do. So I really hope that you learned a little bit about user interface and game design here, right? What are the psychological tools that designers use to make something more satisfying? And I also hope that I gave you something that you can take away and back to your classrooms for making your JavaScript programs and making your students' programs a lot more fun and exciting to use. There's a whole world out there of design like this. There's a lot you can learn about Juice and satisfying design. So I hope that this kind of unlocked that for you. And if you make something really cool using juicebox, please share. This was actually a presentation that I gave to the CodeHS team. And I think a lot of us had a lot of fun taking our programs from the JavaScript course, adding Juice to them, making them a little bit more exciting. So please share on Twitter if you make something cool. I'll be sure to retweet it. But other than that, this has been great. It's been such a delight to be able to present this to you. This is a topic I really love. But otherwise, thank you so much.